Good morning, sir.
Yeah, good morning. Okay, glad to see many people here. So after a long break, which was unexpected, VT exam we have conducted. Okay, so I will tell you about that VT later. So we will get started with our revision. So you may ask, sir, whether we finished the syllabus. You are starting revision. So yeah, so we have to assume that we have finished because what is needed for term end we have completed. Because after all, only one question can be taken from each unit, and fifth unit is like very huge. So even fifth unit itself I can teach one semester. Then last unit is seventh module, DBS, TV and GPS. Even that also we can teach one semester. So we have to draw a line somewhere, and we have lost many classes also. So four classes in the last week, and before that also there was a semester break. So there we have lost many classes. But anyway, because of the pandemic, since the question paper is within our control, so there is not much to lose. And if you are really interested, you can always study on your own. Right. Okay. So coming to the modules 7 we were discussing, I think. So that day not many students were there. So you can have these recordings of last two, three classes and go through them, because at that time also you may be in some other mood, and even today also I don't know. You may have some other quiz or lab exam or J component review. So if you are not in a position to understand, you just download the recording after the class. And when you are studying for the exam, you can play that recording. Okay, so module 7, we were discussing about these two main components are there in the module 7, DBS, TV, and GPS. So one is that in the DBS or direct broadcast television. So basic thing is the DTH, direct to home. So within this direct to home, there are two options. Like first option is this TVRO. So TVRO is TV receive only, which is slightly more powerful and more costly and has more facilities, and there is no compression of the video data, so very high resolution data is available. And but the problem is that because of that higher bandwidths, one satellite cannot offer a many large number of channels. So our TVRO receiver should tune to multiple satellites, and therefore it has to have a steerable antenna where you can steer the radiation pattern of the antenna to different angles. So, and the receiver is also bulky. So instead of that, they have gone for the DBS TV. So DBS TV is the actual the dish TV things which we have in our homes. Okay. So are you able to see my screen?
No, sir.
No, sir.
Okay, okay, okay. I'll just share the screen.
Excuse me, sir. Exam will be open book, sir.
Which exam?
PAT exam, sir.
No, I don't know.
Sir, what
No.
about quiz?
Yeah, quiz Friday will conduct during the class hours itself. Friday 11 o'clock we have class. So both the quizzes together I will conduct. So evening I will send you the link for that classmarker.com. There you have to create your login and password. And today evening or tomorrow evening I will just have a mock exam with few questions so that you can see whether that system is working or not. So that during Friday we won't have any problem.
The
So
website.
classmarker.com. So
Okay.
once I will configure the mock test and I will give you the, I don't know whether they will give link or they will give the entry code. So based on whatever they are giving, I will circulate to few students. If it's working, then Friday, then I will send you. Okay.
So cat syllabus.
Which syllabus?
So for quiz cat 1, cat 2 syllabus.
No, full syllabus. Okay. So there is no limit of the syllabus. Full syllabus starting to ending. Okay.
Okay.
So yeah, anyway, you are intelligent. No, why you are worrying about all that? If you use your mind, then the answers will be easy. But if you use Google, then time will be wasted and you won't get the answers also. Okay. Anyway, now are you able to see the screen?
Yes.
Okay, nice. Okay. So I was telling about these two things, TVR and DBS receivers. So then direct broadcast satellite DBS services are like this. So this is the overall operational diagram, and here at the receiver, the signal will be received, then through a low noise amplifier, it will come through the coaxial cable till the set-top box. So inside the set-top box, that digital demodulation and decoding will take place, and the analog waveforms will be sent to the TV set. So this is the overall high-level block diagram, but we can also have a exact system level diagram also. Like this is for the receiver side, and this is for the sorry, this is the data. That what is that? Okay, yeah, this is for the uplink transmitter side. What is happening? So this is the detailed block diagram. You are supposed to draw this. Like one question, module 7 will be one question will be describe the operation of a DBS TV receiver using a neat block diagram. You are supposed to draw this and explain about it. So I will also take the photos of that explanation and put it here in this PPT. Then similarly, another batch may get describe the operation of a DBS TV transmitter. You are supposed to draw this one and write it explanation. And there is error control since all this is digital. So how the error control is taking place. So for the error control, this is how the uh, coding is done, error control coding. So this, if asked, you have to draw that. And if it's a live channel, then it occupies a lot of bandwidth. If it's a recorded streaming, then it only 1.6 Mbps is enough. Otherwise, if you have a live channel, then 6.2 Mbps is needed. So generally, what they do is they mix up the pre-recorded and live videos in order to maintain the bandwidth for the optimal utilization. And then here they have written like what happens if the single word error occurs, like how does it manifest on the TV screen. So if you have a single word error, it will result in a erroneous pixel on the TV screen which is in the wrong color. So that is for the uncompressed digital TV. But if you have a compressed TV, then each word error may influence several pixels on the screen. So then what happens if you have a burst error where several words are of error, then how does it affect the pixels on the TV? Then similarly during the rain attenuation or during the rain, how does it happen? Like so when you have rainfall, so during a rain fade on a DBS TV link where the signal goes below the threshold, So first, initially, you get small squares of incorrect color on the TV screen, followed by larger block errors and then a blank screen. Okay. So as the intensity of the rain is increasing, so from the small squares of incorrect color to large block errors to blank screen, then once the rain is fading away, the things get better, and the signal will be returning above the threshold, and the picture will be rectified and reappear on the screen. So it's not like Tata Sky person is doing something on your behalf. So it's just that naturally only the rain effect of the rain goes away. So simply they will tell to switch off your set-top box and then switch on and then do all those things. So but they are not doing anything. Like one of my relatives asked me, like these people are telling to switch off the set-top box when it's raining. So are they doing anything on the back end for our on our behalf? So I told they are not doing anything. It's just diversity. They are just believing on the luck. Like if it's faded now, if there is lot of channel fading now, after few seconds or few minutes, the fading may pass away. So based on that diversity reception, they are trying to they have a hope that the channel condition may get better, but as such they are not doing anything on your behalf at the back end, right? So the credit is going to the dish TV person. Like people were thinking when it was raining and when you switch off the set top box, Tata Sky people are doing some repair in the background. Okay, so nothing of that sort. Then we have seen about GPS also, like describe the GPS, simplified GPS receiver. So you have to draw this and explain what are the different errors in GPS, these five, six things, and how exactly the positions are calculated in GPS. So we need to listen to three or four satellites and calculate our position based on that received data. So all these are in CDMA modulation. So we have to take that PN sequence of the particular satellite and decode its data. So like that, we have to listen to three or four satellites. Three satellites for position determination, fourth satellite for eliminating any timing errors. So then inside the GPS navigation message, all these things are there, different subframes in the header and all these things. So not really necessary unless you are doing this type of analysis. So same thing I can show you in the textbook also. Where is that? Yeah. So as you know, three questions. So three sets are there. One is DBS TV receiver, one is transmitter, and one is GPS. So GPS, there are different segments. In the space segment, you have a constellation of satellites. Then in the control segment, you need some mechanism in order to control or monitor those satellites. And in the user segment, we have a GPS receiver, which is having all the software needed to decode all these signals, software and hardware. And this is how the receiver looks like. And so in the space segment, you have the satellites. Control segment is all these things: antennas, monitoring stations, master control station. So, and all these things, how does it actually operate? Is principle of operation is based on the trilateration. So, like if you know radius, if you know the distance from a particular satellite, you make an imaginary sphere of that radius. So you are anywhere on that sphere. But suppose if you get the data from another satellite also, then you are at the intersection of these two spheres. You know the distance from one satellite, you know the distance from another satellite. So you are somewhere on this circle, which is formed due to the intersection of these two spheres. Okay. So now third satellite also, if you get data, then you are at either of the two points where these three spheres are intersecting. And once you know this, you know your position, and fourth satellite will give the exact timing so that you get the proper location. Then signal structure is also very much detailed, not needed at this point. So how all these, there are two codes. One is the P code, that is called precise code. C by A code is the course acquisition code. So in the starting, the satellite gets only a course data, like approximate data of the satellite, and after tuning to it, it gets the precise data using this P code. So this also is like 3-4 pages, but not needed now. So then how those messages are decoded and how this range is calculated, all that is there. Then exact range determination of a receiver location is like this, using the information from at least four satellites. So basically, we want the XYZ coordinates of your receiver. So for all, this is the trilateration method which we use. And then you have those position methods. So positioning modes are two. One is point positioning and the other one is relative positioning. So point positioning is the general thing with respect to satellite. With respect to the satellites, where are we? Like we want just our location, like XYZ. Relative positioning is used in differential GPS. So there, what happens is, uh, like we are not concerned about our own location XYZ. We are concerned about our location relative to some other point. So what happens is, suppose if you know a particular location, like you know Taj Mahal. So Taj Mahal location, you know where is the XYZ, and near that Taj Mahal, you will put a GPS receiver and find out the readings. So then you will know the accuracy of the GPS system, like how much error it is giving. And the base station, which is located at that Taj Mahal, sends out the messages to all the nearing GPS receivers that this much error is there in the GPS calculation. So, and all those receivers can retune their position. So that is one application. So a known for a known location, we know already, we know its coordinates. Now we are seeing how much the GPS is giving. So based on that, we will find out the relative position. So this relative positioning is important when you want to reach to the airport terminal, or landing of the aircraft, or landing of the ship, when you want to bring it to the port. So there, it's uh, it's of no use to get the XYZ location of that ship, but it is more important to see how much relative to the harbor, how is it oriented. So that is more important. That is used in the differential GPS or relative positioning. So all these you can write. So yeah, that was the module 7. Those who didn't come. So then we will go quickly and see how is the terming pattern. So as far as I know, it is open book only. Why suddenly you are raising questions whether it is open book or not? Whether you got any mail? No, right? Okay.
No.
Yeah, it's something like listening to the whole of Ramayana and then asking who is Ravan, like that. Full 3-4 semesters have gone in this corona, and people are asking whether it is open book or okay. So overall question pattern, you know, 7 modules are there, one question from each module, and you are supposed to answer any 6 questions. So in the background, it also means you can study only 6 modules. So totally 3 different sets we have prepared, 21 questions with randomized questions. So it's like if you get 1B, you may not get 2B, you may get 2A or 2C, then 3B, something like that. So only 15 marks is the numerical. Be careful about this. Overall, out of 70 marks, 15 marks is numerical, remaining is theory. So those who don't like theory, you prepare well. So modules 1, 2, and 5 is 5 marks theory, 5 marks numerical. Remaining all modules are 10 marks theory. So paper is not easy, and if you draw more diagrams and explain properly, you will get more marks. And whoever is typing answers in Google and writing that will get very less marks. Out of 10 marks, only 1 or 2 marks you will get. Okay. Okay, so then module 1, what are the frequently asked questions? So what is a satellite? What are the applications of satellite? You know, communication applications are like satellite telephony, satellite TV, satellite radio, then satellite, what else was there? Yeah, this satellite, the data, like data communication through satellites using the VSAT terminals. Yeah, module 6 was also there. VSAT we have studied in detail. Then types of satellites are also the same. Then satellite service is also the same. And then what are the frequency bands of the satellites? So something like this: L band is this much, S band is this much, C band is this much, Ka band is this much, Q band is this much. So those are the satellite frequencies. Compare satellite communication to terrestrial and fiber optic services. So compared to the terrestrial, satellites provide some flexibility because they are covering a large area on the earth, and installation is relatively easy as you can overcome the limitations of terrain and water bodies. But if you want a fiber optic, you have to dig those cables and lay out those equipment. So it's difficult to cover in a forest area or a hilly area, or when you have large water bodies in between the landmass. So all that you have to write. Then we have those orbital mechanics and Kepler's laws, like attraction, repulsion, centripetal, centrifugal forces, and how to calculate the velocity of that object, radius of the orbit, and all those things. In the module 1, we have done several calculations, apogee, perigee, all these things. Then numericals on look angles, like elevation and azimuth angles. Then what is the slant range calculations? So these are the important things. Then module 2, these first three answers you might have written in the CAT 2. Sorry, CAT 1. So launch vehicle types and different ways in which you can launch a geostationary satellite. And third one is what are the effects that like affect the performance of a communication system. So then other definitions which you did not write in CAT 1 but which are important are the sun synchronous orbit, geo orbit, and Molniya orbit. So there is a highly eccentric orbit called as Molniya orbit, which is used for offering coverage over the Soviet Union or the Russia. So in the geostationary orbit also there is one normal time period and there is another time period for a stationary observer on the Earth. So for a stationary observer on the Earth, how does it feel? Like how does he perceive? So the formula for that stationary observer in a geostationary orbit will be P is equal to that 24T by 24 minus T. So this is what apparent orbital period to the observer. Okay. So apparent orbital period is, suppose if you have a geostationary satellite which is having the exact time period of the Earth. So T is equal to 24 is 24 into 24 by 0. So it is infinite. So this person sees the satellite to have infinite period. So infinite period means it's not at all moving as per his understanding. So for a stationary observer on the Earth, the apparent period is like this. This T is against the galactic background. Capital T is against the galactic background. P is the apparent position or apparent observing time. So it is infinite. He thinks that it's never moving, or after infinite time, it will come back to the same place in the orbit. So, yeah. Then in assignment, you might have written sun synchronous orbits, all those things. So then numericals on orbit period calculation, orbit radius, Doppler effect numericals. So these are the things which you need to focus. Okay, yeah, sun synchronous orbit is this. So generally for remote sensing and Earth observation, we follow this sun synchronous orbits because it will come back to the same place on the Earth at a given time. Like if you want to observe some Godavari river basin or Ganga, so then it has to come to the same place exactly every day at the same time. So we need to keep it sun synchronous orbit. And similarly, the geostationary orbits were not sufficient to provide coverage to the Soviet Union. Yeah, this was the formula which I was telling. In the geostationary orbit, the apparent period which for a constant stationary observer, he perceives it like this. So if you exactly follow the time period of the Earth, then he sees that the satellite is not moving. Then coming to the elliptical orbits, and Molniya orbit is a typical orbit. Since the geostationary satellites could not cover the higher altitudes of Russia, they have created their own orbit called as Molniya orbit, which is a highly inclined orbit where a satellite spends a lot of time in the northern hemisphere and comes back quickly to the southern hemisphere, and the this perigee point is very near, whereas the apogee point is very far, like 40,000 kilometers. So that most of the time the satellite stays in the northern hemisphere, providing coverage. So and this fellows, Russia is very vast, right? So one satellite is not enough. They want two satellites. So what they do is two out of phase satellites in the Molniya orbit like this. So this first satellite provides 12 hours coverage during the daytime, and the other satellite, which is 180 degrees out of phase, provides coverage during the night time. So that is how these two satellites are oriented. 180 degrees phase shift is available between these two. So they will offer full uninterrupted coverage over the entire Russia, because one satellite period is about 12 hours. So one will provide for 12 hours, and the meanwhile, the other satellite will offer the coverage. Okay. All these things you may have to write. Then sun synchronous orbit also similar to this. Yeah, this is sun synchronous orbit mainly for Earth observation satellites. So mostly we have it in a lower Earth orbit with a polar orientation. So all that details you need to write. Okay, so then going to the module 3. So module 3 earlier we have covered that antenna subsystem, and what else we covered? That space qualification and equipment reliability. Those were covered for the CAT 2. So now the other things are left out, like uh, attitude and orbit control system. Like in the attitude control system, you have the stabilization of the satellite, spin stabilized or three-axis body stabilized. And in the control subsystem, we have to see that the satellite is not drifting through its orbit. So attitude is like orientation of the satellite. So orientation of the satellite is important with respect to the earth station because we need to point the antennas properly towards the earth station. So that's why we have to maintain the attitude of the satellite. And for that, we uh, like we have to go for the stabilization of the satellite. So spin stabilization is based on the fact that a rotating body offers gyrational resistance to the forces that disturb it. So simple example is a spinning top in your home. If you spin any object due to that rotational force, it will overcome gravity and other forces and tries to rotate until its speed is reduced. So like that, if you are able to maintain spin a satellite at a constant velocity, then it becomes stable in its orbit and other forces cannot disturb it. At the same time, the antenna has to be put on a d-spun platform. So how much spinning you are providing to the rest of the body, that much d-spun you have to provide to the antenna so that it is looking stable towards the earth station. So that is attitude subsystem. Then we are not asking that, we are mainly attitude and orbit control system. So orbit control system is important. We have to avoid the satellite from drifting away from the desired orbit. So for that we have to do station keeping, avoid drifting of the satellite from the orbit. This you can study from the textbook. And avoid drifting of the satellite from the orbit. So we have to perform station keeping. Like within station keeping, you have left, right, or up and down, named as east, west station keeping or north, south station keeping. So if you see that the satellite is moving towards left or right, then you have to use those thrusters or motors which bring it back into the proper orbit. That is called east-west station keeping. If it's drifting up and down in the orbit, then you have to fire those thrusters in the north-south direction, which bring it back to the proper place. Then we have the another one is telemetry tracking and command system. These are straightforward questions like describe the operation of a orbit control subsystem. Uh, 10 marks. Describe the operation of telemetry tracking and command subsystem using a neat block diagram. So in the telemetry, it's like telemetry is like during the operation of a satellite, various onboard sensors and all that data is gathered and that is sent to the earth station through a telemetry link that gives the health of the satellite. And tracking is like during the initial phase of the satellite launch in order to track whether it is going in the proper trajectory or not, or even whether it is going in the proper orbit or not. So this tracking will be used. And command subsystem is like in order to provide remote commands from the earth station. If you want to switch on some transponders, or if you want to switch off some transponders, or if you want to switch on some redundant entities in the onboard the satellite. So whatever you want to do, all those commands can be given. Then you have the power subsystem. So in the power subsystem, the main function is for the solar panels. So why only blue light solar panels are used? Why not blue light sensitive solar panels? So blue light sensitive solar panels provide the highest amount of illumination. Therefore, blue light has the particular wavelength where there is heavy irradiance. So therefore, we use only this and it provides more efficiency. So that's why solar panels are generally in blue color, not green color or red color. Okay, so this answer and then how the power is distributed within a satellite. So for this module 3, I will provide notes because we never covered these aspects. And now there is not time, but these are easy only, not much difficult. So how the power is distributed, like you can draw a simple pie chart, like 80% of the power is occupied by the high power amplifiers and traveling wave tube amplifiers. So basically amplifiers take up a lot of power in the onboard the satellite. Then 5% is used for receiver, 5% is used for receiver, 5% is used for telemetry tracking and monitoring device, 1% is used for the buses on the satellite, like buses are the connecting wires and all those. So like that, similarly, some remaining percent is used for something else. So this is the pie chart distribution of electrical power on board the satellite. Okay. So all these things you can easily write, and these two were over in cat 2. So now again we will not ask them. So you need not study them again. Okay. So how much time is left? Okay, some more time is there. Yeah, so then this is what module 3 over. So I will delete this slide because it will confuse you. This was for the cat 2. Now it's not relevant. Yeah, module 4, you have this different things like FDMA, TDMA, CDMA, then polarization division multiple axis, then space division multiple axis. So all these definitions and what are their nitty-gritties you need to study. So space division multiple axis is you use the same frequency in order to cover two different geographical locations. Suppose Africa and America, they are geographically separated, and the antenna which is pointing towards the America, it won't point towards Africa. So that type of directional antennas have to be used. If you are really able to do that, then you can use the same frequencies for serving both these continents. So that is called space division multiple axis. Similarly, polarization division multiple axis is like uh, same America you can cover in horizontal and vertical polarization. So many channels, double the number of channels can be transmitted by using this polarization diversity, whereas the frequency can be same. So within the same frequency, you supply 500 channels in horizontal polarization and supply 500 channels in vertical polarization. That is PDMA. So details of all these five schemes that was in the module 4. No numericals this time from module 4. So then describe about this SCPC and MCPC systems. So SCPC is single carrier per channel and multiple carrier per channel. So it is like from the satellite transponder, like the transponder will allot some bandwidth for each of the earth stations. Now within the bandwidth allotted to a particular earth station, whether that signal is belonging to a single user or multiple users. So whether that station has previously multiplexed many users data or that data corresponds to a single user. So that determines whether it is a MCPC or a SCPC system. So in the MCPC system, that station itself performs the time division or frequency division multiplexing at its end and gathers all this data as a single data and sends to the transponder. So that is multiple carriers per channel. And SCPC is like the earth station is not performing any multiplexing. It belongs to a single user's data. So that data is directly sent to the transponder. So what are the possible modulation multiple access techniques for all these things? So basically in HCPC you have FM modulation, and so in HCPC you have FM modulation, FDM, and multiple access, maybe anything FDMA or something like that. Then MCPC, there is no FDM, sorry. FM, FDM. TDMA, or you may use PCM and FDMA, PCM and TDMA. But in MCPC, you have like individuals data will be FM modulated, then earth station will perform frequency division multiplexing, and finally it will go for the transponder. Or if it's a digital data, PCM, then TDM and TDMA. So these all these things you have to write. Then what are the different transponder assignment modes? Sir, whether you taught all these things to us earlier? Yeah, this for module 4 we have extensively studied. All this we have taught. Transponder assignment modes like those PAMA and DAMA and random, what is that? Random assignment. So, so this is permanent assignment. This is demand assignment, multiple access, then random assignment. So based on that, you have to explain what is the situation. So if you have long-term earth station and long-term commitment, you have to give a permanent access for that earth station. If it is like a mobile telephony or satellite telephony where only bursty data is there, not so frequent, you have to go for the demand assignment. And some other places, you leave it to the devices, that is random assignment. The devices themselves undergo contention, and whoever wins get the chance to transmit. So these are the things. Other important things like I don't know what was that, intermodulation distortion, then synchronization, TDMA frame structure, TDMA frame structure and efficiency of the TDMA, all that is not there. Okay. So then quickly I will write modules 5 also. So generally this was not the way I wanted to end the semester. So very few classes. So actually I wanted to tell more details about module 6 and module 7. And one last day I wanted to show Mission Mangal during the class within 1 hour. But anyway, it's okay. Module 5, three main questions are there. One is that path loss derivation, path loss, received flux and received power, flux density and power received at a given place. Then associated with that numerical, find out how much path loss is there, how much received power is there, or how much flux density is received at a given place. Then the second type of question is G by T ratio. How is it linked to the C by N ratio and calculation of the G by T ratio? So numerical. So all these are there in that module 5 PPT. Then the third one was using that noise figure and noise temperature. So equivalent noise temperature of a cascaded system. You have G1 T1, G2 G2 T2, G3 T3. So what is the link between noise figure and noise temperature? So noise figure minus 1 into T naught, if you do, you will get the noise temperature. So this you have to write. And numerical, like overall equivalent noise temperature is T1 plus T2 by G1 plus T3 by G1 G2, using that formula. But before that, you have to be careful that all these values should be in the normal scale. So if G1, G2 are given in dB scale, you have to bring them back into the normal scale. So only three main things for the module 5. Then module 6 also I will show within 1 minute, because already you know that. So Friday's class initial 5-10 minutes. If you have any questions you can ask. So the VSATs are generally to eliminate the middleman in the received architecture to remove the hierarchy. Distribution hierarchy is not needed. Directly, the signals have to be sent to the receiver or the end user. So that is the motivation behind the VSAT terminals. So then how is connected and all that we have seen. What are the applications of VSAT? What are the capabilities of VSAT hub and VSAT terminal? So hub is a central station with more facilities and more complexity and more resources. Terminals were designed to be low cost and low complexity devices. So they have less facilities and less scene. Okay. So then what are the types of implementations? One way, two way, and split type A implementations. So one way is for the broadcast, two way split IP is for the internet related services where the reverse channel is through a telephone link. Two way is like two way you can go. You can receive as well as transmit the information in inbound and outbound channels. Then for the two way you may have star implementation or a mesh implementation. So all that we have seen. How does the satellite pursue star and mesh topologies? And what are the delay considerations? Like you have to integrate them with the terrestrial IP network, packet network. So the delays and the window design, everything is different in the terrestrial network. So you have to adjust the protocols such that it matches to the delay of the satellite system. So because satellite has 260 milliseconds round trip delay, so you have to adjust all those protocols according to that. Yeah. Okay, so this was the thing which I wanted to show you. So those who have any other lab or no, you won't have lab. If you have any quiz or anything, you can log out. Others who are free